All right, we're just about to get started, folks. Welcome to those who just logged on. Please do mute your microphone. Later on, when we're done and we have Q&A, we'll have a chance, hopefully, for people to unmute and ask some questions live. But for now, please do mute your microphone. We're going to get started here with this session in just a minute with a video. This is on a case study of 4 basin retrofits in the Silver Spring Township in Cumberland County. We have Sean Fabian here from HRG. Unfortunately, Tyler Erb from Silver Spring Township was not able to make it, but Sean will be covering this session on his own. So again, please mute your microphone. If you're not speaking, if you look at the top of your toolbar there, you'll see a little microphone icon next to the video icon. Just click that and you'll be able to mute your mic. Are we ready with the video, Rachel?
Here we have a basin that's accepting drainage from a subdivision. It's real close to Silver Spring Road, and there are some drainage issues on flow. We're in a very flat limestone-based geology part of the county, so there are a lot of issues with appropriate fall and discharge away from the basin. So if you could see this little hatch pattern, we have a discharge that just kind of sits in this area until it floods up enough that it finally moves out of this drainage area and along its way. So we were trying to solve issues like that as we could. So we're coming in, we're redefining where the emergency spillway should be. We're trying to establish positive drainage and grade. We're replacing infrastructure that's failing and putting a new outlet structure in for this Cicada basin. We're also doing quite a bit of landscaping and replacing the bottom with an amended soil so that we can do a planting of the bottom with an Ernst mix. These water quality plantings should help with reduction of sediment, reduction of nitrogen and phosphorus. All right, so I'll take back over the screen share here and kind of move through the presentation. If you're just joining, unfortunately, I had a backup from Silver Spring Township to join me in the presentation, and he just got caught out into the field. So I'm going to be flying solo on the township's portions of everything here and walk through all the steps along the way. So. Good morning, everybody. My name's Sean Fabian. I'm a project manager with Herbert Rowling and Grubik based out of the Harrisburg office, and I work closely with a lot of MS4 coordinators and on their pollutant reduction plans in the Cumberland and Dauphin County areas. And today we're going to be walking through a little bit of the MS4 permit requirements and planning and the Chesapeake Bay Pollutant Reduction Plan in Silver Spring Township. How funding was established for some of their pollutant reduction plans, and then the design, permitting, bidding, and construction aspects. And I've been involved through every step of the way with that, from major revisions to their Chesapeake Bay Pollutant Reduction Plan, through the initial grant acquisition and stormwater fee establishment to fund a lot of the work going on. So here's a view of the overall township. For those who are not familiar with where it sits, it's kind of between the borough of Mechanicsburg and the top of North Mountain, kind of in the north central part of Cumberland County. The north of the Gwinnett Creek area, which is this kind of twisty, flowy creek coming through the middle of the township, is a shale-based geography and has a lot more stream channels than the southern portion, which is mostly a limestone-based geology, which is a very flat, fertile, largely agricultural part of the county. So part of the pollutant reduction plan sets up to reduce sediment by 216,119 pounds per year. By 2023, there are a number of different BMPs that have been selected for stream restoration and basin retrofits to accomplish that goal. And the main goal was to try and complete projects in the township that were owned by the township wherever they could, just to facilitate the ease with planning and performing the work. And also in this new plan to try and build better redundancy. A lot of the plans that were drafted in 2018 targeted the base reduction in sediment. And as anybody who's done any kind of permitting and design and construction is aware, that you'll have a number of issues that pop up through the process where you'll have a landowner issue or an environmental issue or something that happens that delays or otherwise cancels a specific site as you go through design. So we did find additional options for projects on some private landowners and some other partners that we could potentially work with if we had issues moving forward with our original plan. So some of the pollutants of concern, you know, we are in the Chesapeake Bay drainage area, but we do have two smaller streams that discharge into the Conde de Gwinnett Creek, Hoagstown Run and Trindle Spring Run, that are both impaired with pollutants of concern. And there are additional appendices that the township has to comply with because of that, either through pathogen or PCB or siltation. So specifically, we're going to talk about these 4 basin retrofits. They're all owned by the township and in the lower southeast corner of the township, all draining to either Chesapeake or the Trindle Spring Run or the Chesapeake Bay drainage area. Each of these have varied drainage areas coming to them in varied sizes. So they have a number of different types of load reductions. As you can see, based on that 216,000 pounds, we're attacking very, very small components of sediment in these, but we were trying to take a look at some of the older basins and infrastructure in the township to see if we could address other rate and flow type concerns that were available. So initially with funding, they were moving forward with development of a stormwater fee, which is now in place and has been collecting since, I believe it was January of last year. They did set a fee of $9 per equivalent residential unit and found that the residential unit average for the township was about 4,000 square feet. There is a flat rate for residents, and then they do multiples of the ERU for non-residential parcels. So that's helped fund some of the program. They've also been trying to obtain grants to tackle various aspects of their PRP project to hopefully offset some of the costs so that they could deal with some of their failed corrugated metal pipe infrastructure in the township instead of spending everything on their pollutant reduction plans. They are successful in obtaining $350,000 from Growing Greener this last cycle at a 50-50 match. And that actually is enough money to pull a 5th basin into this contract that we're starting the design on now. So I did review this Cicada Basin in the introductory video, so I won't go into much information on this, but it is an existing basin in a residential subdivision. There's only a concrete end wall with no orifice plate, so there's no small storm rate control, no real volume control set up. This is a relatively older basin, and a lot of these older basins that have no orifice control are really giving limited sediment reduction capabilities of 10% reduction of the load that's actually coming to it. And there are a lot of issues in this part of the county with very, very flat areas and having trouble with daylighting of pipes and positive flow to ensure that water is traveling to the final destination and some of the surrounding streams. And we did notice that there are a lot of issues with where spillways were located, where they discharge. This one in particular, we have an access off of Silver Spring Road, and there's a cross drain to allow road drainage to pass under this access, and then the spillway dumps right onto the access. So it's not really advantageous because the only time that we really need to get vehicles in there for maintenance is when you have some of those higher events or some of the routine maintenance. So it was not advantageous to have the spillway dump exactly where you need to access. So here are a couple photos of the end wall with a little bit of a trash rack. The main stone channel discharge of the residential flow coming into the basin itself. And we did review through in the video some of the improvements. So we're adding an outlet structure, we're increasing storage within the basin by lowering it, we're restoring positive drainage, and we're trying to put in the amended soils and landscape plantings. We did have infiltration testing in all these basins. as a lesson learned from some previous projects that I got into, I would strongly recommend doing infiltration testing in each of your basin retrofits. It's amazing what unknown discoveries you have as you dig a hole into the ground that people were not aware of as you plan out these BMPs. So we've had a number of times where, a failed under drain nobody knew existed, terracotta pipe that was part of drain field was discovered. You have failed infiltration and instead convert your whole concept into a wet pond concept. So I do strongly recommend that those take place. Here's a profile of the new basin where you can see that you do have a little bit more establishment of a better drain, a better storage volume within the basin itself, because we dug down the area before we install those amended soils. So the cut through this area will be an additional 2 feet to put those amended soils in, and replacement of infrastructure, adding that M inlet style structure so that you could have a discharge location and a little bit better control of volume. And looks like some of my bars aren't lining up very well there, but to design a lot of the efficiencies, we use the expert panel report. And then we tried to use a stage storage elevation guide to set up what we would have as an overall storage volume in acre feet so that we could figure out the runoff that would be treated, and then go to the chart to figure out what our actual sediment removal would be within the storage elevation. And there's some learning curve with some of the folks that are not as used to some of the design criteria that goes into designing these basins, such as, you have a spillway elevation, then you have your top of berm. So a lot of your efficiencies are built on that spillway elevation. So there's a freeboard. So you do have to take what your sediment removal is at the top of that spillway and not the actual top of your berm. And we came up with a number of different efficiencies. And this actually changed some of our initial plan as we were evaluating some of these basins that we thought were going to have substantial reduction in sediment, actually, because of the geometry of the basin, had very, very limited sediment removal efficiencies. So when we took a look at the cost to construct versus the amount of sediment reduced to look at a dollar per pound of sediment removed, we had some basins that we were originally planning for that were not very economical to pursue. So that factored into some of the selection of these four. Another basin is North Konhaus. So this is off a state road, which is a PennDOT-owned road. We had some different challenges in this basin. It was a much shallower basin, and it was very tight between the discharge of the basin and the actual cross drain under state road, which created a lot of maintenance challenges when you have two pipes meet and no way to effectively get in there and keep them clean. So this is, again, another existing basin in a residential subdivision. There's a concrete end wall with no orifice plate, so there's no small storm or volume control in it, and has minor sediment reduction potential. And there's also additional issues with positive drainage at the outlet due to this crushed pipe under the road. And there was no emergency spillway in this location at all. So I have a couple of views here on the left. You see the pipe's completely buried and it's crushed. There's an issue with lack of cover that resulted in the CMP pipe being crushed. On the inlet side, or the outlet side of the basin itself, we had a lot of rock and debris that was filling up that pipe as well. And you can see that it's a very, very shallow basin in this area. So again, trying to take a look at how can we improve this basin. We had some short circuiting between the inlet in and the outlet out of the basin. So we tried to install a earthen berm to route around flow and try and take more effective use of some of the dead spots, putting in different landscaping to help with beautification, with amended soils and sediment, nitrogen, and phosphorus reduction, and then reestablishing a little bit of the roadside drainage and installing an M inlet to make it a lot easier to help maintain, clean out of this connection point between the basin barrel and the actual cross pipe across the road. And then we actually went with a squash pipe in this location and adjusted some of the inverts to try and improve some of the cover that were presenting a challenge, and then to actually provide some grading to daylight the pipe so the pipe wasn't, discharging to ground higher than its invert to discharge to. So we did raise the berm. We created an emergency spillway. So we improved some of the actual storage and volume there. We're adding an outlet structure so we can control some of the lower storm events, increasing that flow length through the basin. So hopefully you have more contact time with the amended soils and all the plantings in the bottom to help with sediment reduction, as well as nitrogen and phosphorus, and replacing failed pipes. So we do have highway occupancy permits on this site for both access to the location as well as the utility replacement with the cross drain. So here's a profile view of the basin. So you can see that we are improving a little bit with storage capacity by excavating down and improving the height of the overall basin itself. One of the big advantages are us lowering the pipe to produce more cover, and we accomplish that largely by reducing the invert as well as adding on a squash pipe and then grading to daylight for the basin. And again, we utilize this stage storage curve to figure out, based on the elevations, we know the square footage and area, we know the difference in elevation, so we can figure out the incremental storage changes to come up with what our overall total storage volume is going to be in acre feet, so that when we did our hydrology assessment, we know exactly how many inches of runoff we're treating, to then follow up with the chart from the expert panel report to figure out our basin efficiency. South Konhaus is a basin just south of that North Konhaus Basin. Again, it's right off a state road. This one was a little bit more of a challenge because it was pinched between two existing residences, and we had a lot less ability to manipulate the top of slope because we had some utility poles out there. So this one was a lot more of a challenge. And it was interesting trying to walk through with PennDOT because of that, because they wanted us to add a spillway where this looks like it was just kind of a hole in the ground dug, and a spillway is not considered in the initial design. And because of some of those utility poles, we couldn't really raise the berm to construct the spillway. So we tried to modify the hydrology the best we could with the facilities we replaced in the proposed condition. Again, you have a concrete end wall, no orifice plate. You'll see a common theme in the basins that we were deciding to go after. They are all limited reduction in sediment potential and had issues with positive drainage. So in trying to select the BMPs that we went after retrofits for in that pollutant reduction plan, we did try to choose older basins that required some maintenance, that had additional drainage issues, to try and address as many issues as we could as we flowed through the actual design. So here's some photos. You can see it's a relatively shallow basin again in a residential area. And again, all these basins were owned by Silver Spring Township, so that made access to and design of go a lot smoother since it was their own property. Here you can kind of see a similar setup. We have short circuiting, we have an earthen berm to help encourage lengthening of the flow. We're replacing the barrel, installing an M inlet so we can control roadside drainage better, replacing the crush pipe with a squash pipe, and trying to provide additional grading to help daylight the pipe. And we did raise the berm. We're adding the outlet structure. So all those are providing substantial reductions in rate, improvements to volume control, increasing storage in all of these BMPs. And again, here's another cross section. You can see we have a substantial raise to the basin berm and a little bit of additional capacity as we dig down into the existing grade. You can see some of the issues we had here with existing grade and fall with the deepened structure. So we'd have to grade out quite a ways to provide positive drainage. And that's actually one of the things that's really delaying this project. We need drainage easement and temporary construction easement from the Traditions of America. It's a homeowners association for a 55 and up community in the township. And that process has delayed the start of construction significantly on these two projects specifically. So again, we came up with our stage storage elevation to figure out what our overall runoff treatment was, to run that through the sediment removal curve chart from the expert panel report to come up with the overall sediment efficiency reduction for the basin. Our next basin is actually at the Township building. The Township decided if we're forcing a lot of other people to do this as a standard of design now for new construction, and we're investing a lot of money through the stormwater fee and grants to do retrofits throughout the Township, it's probably good to put our money where our mouth is and do the same with our own basin. So they had a pretty fairly undersized basin that was constructed for the initial site. That really was not seeing an awful lot of water because, again, it had just an orifice plate for higher flow storm rate attenuation and wasn't really providing a lot of benefit for your smaller storm events. So this is existing. All of the municipal complex, their parking lots, their buildings, their police force all drained to this location, and they just have a metal plate onto the outlet for orifice control. There's no emergency spillway and very limited storage. So you can see the orifice plate. It's really just restricting the opening of the pipe. It's not even really allowing any kind of impoundment of those smaller events to occur behind it. And there's been some sedimentation over the years at the outlets of the pipe that we're restricting some flow as well. So we're trying to deal with short circuiting again. Having an inlet right next to the outlet really didn't provide any kind of retention in the flow length here. And we're trying to greatly expand the basin as it sits. So you can see a little bit faintly the existing contours on this eastern side is being pushed out substantially on the other side. So that's one thing you don't really see in the profile view that I'll pull up next, but it did drastically help the amount of storage we had so that we could provide better rate attenuation across all the design events. So here we have, again, a profile. There's not as much excavation down. We expanded more to the east in this to provide additional storage, and we're putting an M inlet so that we can control some of the flow events a little bit better and have a little bit better control of our higher storm events, since there's nowhere really to discharge an emergency spillway to on this site. And again, utilize the stage storage curves. As far as permitting requirements, each basin had independent utility, was geographically separated, and could be constructed in any order, so they are not reliant on each other. So since they are all below 1 acre disturbance, none of them really triggered the need for an MPDES permit for the retrofit. The county was notified through, the Act 14 notifications anyway, just to make them aware of the project coming. And we did have some coordination with PennDOT for their HOPs. So we have an access and a utility crossing HOP through PennDOT. So the bid ran the fall of 2020 for planned construction this spring. Easement finalization is delaying the HOP permit issuance and project start. So the selected contractor for the winning bid, we've been coordinating with them quite a bit to keep them apprised of the easement acquisition progress. And so far, they've been able to continue on other work they have on their schedule while they wait for our full authorization to move forward. But we are hopeful in the next couple months here that we can get in there with them and perform these restorations so that there's enough time to perform all the plantings by this fall and have everything complete and stabilized before the end of the calendar year. So construction currently is pending. Some lessons learned. The big one was on easement acquisition, that as soon as your design is finalized enough that you can approach the landowners and start talking easements, it's a really good idea to do so. We did not anticipate that the easement with the traditions of America was going to take the time that it's taken. So I guess we talked to the old leadership at the HOA initially when we started to pursue design, and they were very receptive to the easement. And we did not gain the intel that apparently there was going to be leadership changes within the organization as we went through the design process. So something that was a verbal handshake, yeah, this is no problem at all, has now turned into a very lengthy negotiation where the development is trying to close out of their MPDES permit. And even though we have no overlap with their actual construction area, they have a lot of concerns that this acceptance of the easement is going to somehow disrupt their ability to close out the permit, which should not be a problem at all. But it's really stalled a lot of our negotiations on this. So it's taken a much longer timeline than we originally anticipated it would to acquire those easements. So please work through all your required easements as early in the process as you can. Open and honest communication on what you're trying to do, what you're trying to accomplish. The need for it really helps with some of those negotiations. And understand that, you know, sometimes the ability to come in and get approval to even have temporary construction easement can drastically affect your ability to start construction on a project. Another item, permitting timelines. Please plan for additional processing time due to COVID-19. A number of agencies, because of the remote work situation and adjustment to, and the delay on construction for the early part of the pandemic, now that construction process has intensified to try and catch up on where folks felt they should have been before the delay occurred, has really increased a lot of the review load that these agencies are experiencing right now. And it's caused a bit of a backlog as we process through that. So do plan on additional time for all your permitting. You know, if you traditionally got a general permit, say in 2 to 3 months, it might be taking, you know, 4 to 6 months now. So that's something to definitely be aware of as we move forward. And all easements need to be finalized before you get your HOPs. So that's something that we've been having a lot of discussions on. That, well, why don't you have the permit yet? We don't have the easement yet. These are all dominoes that need to fall in a certain order. Until we get the easement, we can't get the HOP, and we cannot start construction on those basins. So it's really holding a lot of things up. Other COVID impacts beyond the permits taking longer is a lot of the meetings changed from in-person to remote, and that made it very difficult. As you know, simple items that you would just go into the field and work through with an agency and everybody left with an understanding of something now have to take place in a remote environment. And tools like Google Earth have been very helpful for aiding in those types of conversations where, you know, say I forgot to take a picture and I can, you know, pull the little guy down and take a street view if you are lucky enough to have videos of some of your roads in that program. And that did help facilitate and continue moving some of those conversations. But definitely being remote and not being able to huddle around the same plan did create a lot of obstacles for us to work through. There is a materials price escalation due to the supply chain disruption and a lot of supply and demand issues. So if folks have not taken on new projects since COVID hit, to see some of these escalations or shortfalls, it can be really drastic to your overall timeline of a project. You know, if you're starting a drainage improvement project like this and can't get concrete, you know, supplied for weeks and weeks and weeks, that's something to be concerned about because it could really affect your timeline of when you'll be able to wrap up. And with projects like this, there are a number of facets that you have to think about. You know, you have a landscaping aspect to it. So I don't want to wrap up this project in December and not be able to stabilize until the fall and the spring. So we're trying to time everything that it happens at the optimal season for it to happen. Design and construction capacity issues are also a possible restriction right now, that the more work that kicks off, the less folks there are available to do it, and the more of a backlog everybody's working on. So that's something to be aware of as well. So at this point, if you'd like to see additional design data, I do have some additional things pulled up. I'd be happy to answer any questions that you have so far. If we can open up to questions.
Yes, we certainly can. Before we do, though, I just wondered if there was anybody from Silver Spring Township that was able to log on. I know that we had a couple people lined up and both were called to the field. Were either of those guys able to make it?
Not from the most recent text I saw.
Okay, very good.
So
we do have
send their apologies. They have a little bit of a fire drill going out in the field. We're glad I was holding this account from. Yeah.
We do have a question here. What do you think will be the life cycles on these retrofits, and how often will they need major maintenance or refurbishing?
So in part of the operations and maintenance plan we pulled together for the township, we've been trying to discuss how we handle maintenance on the short-term, mid-term, and long-term basis with these, because some of these were built in the 70s and 80s and haven't been touched since. So I think their maintenance to date has just been make sure none of the outfall pipes are clogged. And as long as that was addressed, then they went about their business. So now that we're moving into amended soils with plants and, potential issues with weeding that you have to control invasives, these are becoming much more complicated processes. So we've actually been partnering with some of the stakeholders in the area through the Master Watershed Steward program and other programs to try to come up with educational guidance on, how do you identify what should be and what should not be growing in here, and how do you set up routine maintenance where at least quarterly you're coming in to address some of those issues, and then who provides that maintenance? Can we partner with master gardeners to help with weeding? Can we partner with watershed associations to help with some of the heavier lifts of maintenance on riparian buffers and so forth? So the way the plan is written now, Silver Springs Public Works will be responsible for ensuring that happens, but they've acknowledged that, within all their other duties that they have as the year goes through, there's not a lot of capacity to take on a significant number of these. So when we, try and fast forward 5 or 10 years from now, as we have all the PRPs built out, this could be a heavier load that you need to start working with some of your partners with to ensure that they remain functional. I do feel that a lot of the infrastructure we're putting in some of these locations do have some pretty good longevity. These are all in limestone areas, so we're not dealing with low pHs that might, eat through and erode some of the concrete structures and things like that. So we could have some of these structures, easily last another 40, 50 years before we have to do anything with them. The bigger component is definitely going to be the green side of these basins and how to manage that.
Right. Any other questions out there? You can just unmute your microphone, ask your questions, and then mute it for the answer.
And if we don't have any, I can, pull. I have some other things up here that I can pull and we can talk from if you want to. I do have, kind of the drainage reports and some snapshots of some of the rate impacts. So I thought this was kind of telling that, we had a lot of concerns from those downslope landowners that we're asking for easements. They're like, well, are you helping us out with the storm events? And, it's drastic in some of the events that, and the pre-development, we have 2 CFS pushing out in the pre and in the post because we're now finally retaining that into the basin itself. With 0.4, we had a substantial reduction in some of these storms. And, others, it's not going to be as meaningful, but, across the board, it's definitely a huge improvement to the way a lot of these basins are currently functioning. And we received a lot of interesting comments from the public, well, why weren't these built better to begin with? And trying to explain to folks the evolution of the stormwater program and moving from large storm attenuation only to recognizing the impact of smaller storms, to recognizing the impact of rate only attention to design and trying to pull in volume components. So there's been an understanding growth of how we approach this science and engineering as time has gone on. So things that used to be the standard back in the 70s and 80s are not the standard now. And it was interesting for a lot of folks because I guess they never understood that, things can change like that organically over time. One big issue that's happened in my residential neighborhood specifically, which we didn't think would be a traction point, and I didn't mention here because it didn't come up, but a lot of residents were like, hey, my kid throws baseball in that, and we don't really have a park in close proximity to my property, and now I'm not going to be able to go and throw baseball in this basin. I prefer it to be mowed. Why can't you just leave it the way it is? It's not broken, it functions. And one of the comments we always hear with that is, oh, I never see water in there. It's like, yeah, that's actually bad. You're supposed to see water right after the rain event because it's supposed to hold it back and release it over time. So these aren't functioning as originally intended. But it's tough for some of those folks that, if you have a basin that's been there for 40 years and it's always looked a certain way, to change that now is a huge disruption to what the surrounding owners are used to seeing. And you try and explain that, hey, this could be for the better. Now, instead of, just seeing a lawnmower once a week, you're going to see songbirds and butterflies and other things that you were not getting before, that could really provide a lot of aesthetic appeal and improvement to your property. And, a lot of them, I think, are going to believe it when they see it. And it's a couple-year process till you get established.
Yeah, and speaking of that, we did have a comment here that they very much appreciate that these projects have multiple benefits in terms of addressing increased volume from storms along with water quality concerns.
Mm-hmm.
And another question here, does Silver Spring Township routinely take over ownership of basins located within residential areas?
They do have a number of private or HOA-owned basins, and as we were walking through some of the BMP inspections, there was a lot of discussion around the issues that can potentially create, where the township was owner of infrastructure for a time, then they allowed HOAs to take it over, and now I think they're seeing a lot of value in having ownership of these structures. From some of the HOAs in the area, you don't have a lot of folks on those that generally have a lot of engineering understanding. So when you start talking about the long-term maintenance, I think a lot of these residential subdivisions that were developed, 70s, 80s, and 90s, the last thing you thought about is, hey, let's fast forward 30, 40 years. What happens to this? Who actually maintains this? And if it's the HOA, are you squirreling away enough money to actually attend to that? Because some of these basins have some pretty substantial price tags associated with them. So when you're talking to the tune of, $50,000, $100,000, $150,000 for a basin retrofit, if you haven't been collecting money over time through the HOA, you're not going to be able to really take that kind of cost on, and you're really limited in what assets you have aside from the land. So to borrow against to cover, huge infrastructure improvement needs is really difficult for a lot of them. So I think they're starting to see the value in this, potential municipal owned concept, but it is a diverse ownership of these stormwater infrastructure throughout the township currently.
Very good. Other questions from the group? If you would like, you can unmute your microphone and go ahead and ask it.
And if not, I did talk a little bit about kind of the breakdown and the price per pound type of review. And that was something that previously was not looked at when we were going through the Chesapeake Bay Pollutant Reduction Plan. There was a lot of focus on which BMPs give the highest sediment reduction, and those are the ones we want to tackle. And I think pulling into that mentality of view of, what do you get for the money invested, and what secondary and tertiary issues do we have in these locations that we have additional benefit from that make, some of those less cost-effective BMPs more attractive because you're dealing with multiple issues at the same time. Kind of gave a couple of different lenses to look at this issue through for the municipalities, board and staff. So I thought that was a helpful breakdown. And then it explained a little bit better why I was making the recommendations I were doing. So, we have this basin, the Rife Basin. It's a huge basin with a ton of sediment reduction. And when you look at the price tag, most of these basin retrofits were, 10 to 20, maybe 25 dollars per pound of reduction. The Rife Basin was $180 per pound of reduction. So I'm like, this is not a cost-effective BMP at all, even though it does give quite a bit of pollutant reduction capabilities. So it is important to take a look at those things. And I do encourage folks, look at those types of basins. The two Konhaus basins rose to the top because they had crushed pipes, and there were resident complaints of flooding because of those pipes all the time. So that was a known issue. PennDOT was not circling around to replace the pipes, so we took it on ourselves to push that forward with combining them with the project. Since we were already going to have a contractor there, we met with PennDOT in the field. Their engineers were very in favor of the approach. So we had a lot of, attacking multiple problems with something we had to do anyway.
Other questions, comments? We've got a few more minutes before we log in for our 11:45. If not, Sean, oh, great picture. Thanks
Yeah.
to you and HRG for the work, and good luck with the construction. If we're done here with comments and questions, I would remind everyone once again to use the red leave button to close out this window and then go to your agenda and click on the link for the 11:45 session. So thanks again, Sean, and good luck.
Thank you. I appreciate it. Thanks for everyone that attended.